not connected, so you have to click on plug and play connector. So the next thing which you have to do here, control algorithm. If you go to control algorithm, let me show you again. Setup, control algorithm, and this should be on discrete. This by default takes discrete time, and the PID controller, and then setup algorithm. Here you can give the gain values Kp, Kd, Ki. So initial gain values which we have calculated in the notes which I provided to you, it may be very roughly about 0.003, and then hit OK, and then implement. Don't forget to hit implement now. So if I move this carriage, which has about 3 thick plates and 1 thin plates, so each thick plate is 0.5 kg, one thin plate is 0.25 kg, and mass of the carriage is 0.59, and mass of this rack and pinion is about 0.34 kg. So total mass would be the sum of all these values. You need that mass. So if I move this, there is a change in the counts. So these are controlled by the encoders. So you can go here, command trajectory. So over here, if you go to the step, you don't need to give any counts right now, but the dwell time is 3000 milliseconds. The repetition is 1, and then hit OK. So what it will do, command trajectory execute. So let me go command data, set up the data for the encoder position 1, add this item here. This is sufficient because this is encoder 1. So what you will do, go over here, execute, and record this. So when I run it, if I click on this, so it comes back to this position. So you will record this data, and then plotting, set up plot, encoder position, add to the left axis, and plot the data. So this is what we saw. This is the natural frequency of the system with the Kp gain. I want to show you, you can also export the data from here. Go to the data and export the data. Maybe the Kp value was about, I think, 0.003. So now I want to show you, let's snip this. If we can snip this, set a plot. So maybe print screen here. Okay, we got the print screen. So I want to show you the effect of increasing the Kp over here. Setup algorithm. Let's increase to 0.03. But don't go beyond 0.04. I think 0.04 or 0.06. You will see the notes. And don't forget to hit implement algorithm, hit OK, and then command trajectory, run it. You see now Kp is like increasing the spring stiffness. The more the spring, the stiffness, it will vibrate more faster. So the natural frequency increases. If you go to plotting, set a plot. So you see it has greater natural frequency now because Kp value acts like a bigger spring versus a thinner spring. So if you attach a thinner spring, it will move slowly. A bigger spring, like a stiffer spring, it will move at a high frequency. So then you will export the data. Export the data. Maybe you can give the value which I gave, 0.03. And then you can print screen here. So now I want to teach you how to give the Kd, the derivative gain. So if you go over here, setup, control algorithm, PID should be highlighted, and setup algorithm. Here Kd value, in the handouts I have provided you how to find out the Kd value. So but it is very close to 0.0, imagine this is 0.01, just for instance 0.01 The actual value you will calculate and implement it. So implement and hit OK. Trajectory. This is one. You want to see the effect of adding the damper. So I think adding the damper, what it is going to do. I want to take a look here. Control algorithm, setup algorithm. Let's make it 0.0, 0.02, 0.04. I want to read. KD means increasing the damper. So I've given 0.002 and 0.04 and then hit OK. And then let's see if you can go here, command, execute. I think it tested. So maybe it has done something beyond. The system was unstable. And then next thing you will, what you have to do here. This is not proper. So the third thing is KI. You can give KI for your own learning purpose, but this is not required for this lab. KI, maybe you can give like KI is an integral gain which is used to remove the steady state error. So then you hit OK, implement, and then hit OK. So you will run it. This was an unstable system. So I did it very fast. What I do, I should remove this KI value, set up algorithm to 0 because KI makes the system more unstable. So hit implement. So what I want to see. Did I break something? If you go to the trajectory setup, now you can give counts. Suppose 2000 counts. 2000 counts mean 227 counts equals to 1 millimeter. So if you go over here, hit OK and command execute. I think this is very small, so you can check it. So this was a demo. I'm going to show the plot. This is the old plot. Okay, thank you. I think